Sit. All right. So if you missed the test the other day, it's your responsibility to come make it up with me during one of your off periods, okay? The test is in the grade book. I think for the most part, the class did pretty well. So congratulations. Yep, Ivy. All right, let's bring that up. There you go. All right. So the very first part, first off, did I give everyone the sheet? Everyone's good? All right. So let's take a look at this worksheet. So you'll notice the first problems are just like what we had done. Agree? Okay, so, whoops. Come on, let's go back up. Where'd it go? I think I deleted, pushed that away for some reason. All right, so trust me on how this process takes place. I realize some of you might have a tutor and they might show you a little different way, which is fine. I'm not saying your tutor's wrong, but the problem is you see my way, then you see your tutor's way, and then you incorporate a little bit of each into how you do it, and unfortunately, you start goofing up. So does everyone feel comfortable that we're going to use our distributive property here? So you get 4 times 3x, which is, actually I'm gonna write out each step, and there's a method to this madness for a reason. Do you feel comfortable with what that is right now? Does that make sense? And yes, technically, this would then come out to 12x minus 20. Okay? So that's the answer to what this is. Now, I'm gonna actually do the backwards of this now. Okay? So what would I have to do to get to this? Okay? So, yeah. So what you basically look for is there's multiple ways you could do this. You can sit there and say, okay, what is the largest number on each? And in this case, that would mean that you'd have 4 times 3x minus 4 times 5. And then once you show that this and this are the same, you factor that out, and then you bring your parentheses back in. And then this and this are the same thing. So what we're going to be doing is, it's called factoring, and we're going to start out by factoring greatest common factors, and then it builds upon that, okay? So this particular problem, everyone's okay with, this is the last chapter, 5 times x squared is 5x squared, and then 5 times negative 7 is negative 35x, and then 5 times 3 is 15. So if I were to take it back going backwards, I'd have to realize that's basically the breakdown of what we have. And then you're like, okay, what do I have the same on all of them? And I have a 5 that's the same. And so you could factor a 5 out, and then xx is x squared minus 7x plus 3. Yeah. Okay. But you're okay with the pink, going forward to the pink, right? To multiply, like we did in the last chapter, right? Yeah. Huh? Yeah. Okay. All right. So I can progress through all of the rest of this doing the exact same thing. Do you agree? All right. So the greatest common factor, so I'm down midway. Greatest common factor, or GCF, is the largest factor that all the terms of the polynomial expression are divisible by. Okay? So the greatest common factor, or GCF, we'll refer to it as GCF, is the largest factor. So now I'm kind of down by the bottom of the front page. Is that right? Okay. So let's start on doing these. So do you feel comfortable that I could rewrite this to be 2x and 2 times 4? Does that make sense? Is 2 times x 2x? Is 2 times 4 8? Does that make sense? All right, notice they both these terms have a 2. Agree? So if I pull that 2 out front, this 2 and this 2 get pulled out front, I'm left with an x, the plus sign, and the 4. So if I went the opposite way, last chapter, if I went,
just removing the 2's?
Yeah, you're just.
But
does
there have to be 2 2's or 2 4's.
Yeah, that's what we're going to look at. I mean, this one will be a 3 on number 2, but does everyone feel comfortable that 2 times x is 2x? Does that make sense? Does everyone feel comfortable that 2 times positive 4 is positive 8? So I'm like undoing it. So we had put them together, and now we're taking them back apart. Okay? God trust me, trust the system. I really can get you through. Appreciate you. Okay? So think about what I just did on number 1. What does it look like I might be able to do on number 2? Same idea. Yeah. So 3 times x is 3x. So, yeah, go ahead. So it looks like both of those, I could say 3 times x minus 3 times 4. Is there a number that's the same on both? Yeah, I have a 3 and I have a 3. Agree? Uh-huh. I'm just undoing it. So I can pull a 3 out front. If I pull a 3 out front, I'm left with an x. The minus sign comes along, and then I'm left with a 4. So this is the answer. But the last chapter, what we had done is I would have went 3 times x to give me 3x. 3 times negative 4 gives me negative 12. Okay? So we're baby stepping our way into this. Okay? So that's when we have 2 numbers, but take a look at number 3. Number 3, I have x squared as one of my terms, and then I have 5x as my other one. Do you feel comfortable that x squared is x times x? And then 5 times x is 5x. Agree? Uh-huh. Cool. That's it. So taking it apart. So I have this x that's in common, and then I have what goes in the parentheses now? X plus 5. All right, so again, like if you think that you might have done it correctly, that's awesome. But just do a visual. Is x times x, x squared. I like that. Is x times positive 5, 5x. And if you can say yes to both of those, then you have factored it correctly. So you're undoing, you're breaking things apart. All right, take a look at number 4, and then we'll take a pause. So 3xy is the same thing as 3 times x times y. Agree? And then I have 2 times y. So I have this term and this term. What does it appear that I have in common between those 2 terms? A y. Okay? So if the y comes out front, what goes in the parentheses then? 3x plus 2. Good. And again, if you just do a double check from the last chapter, is y times 3x 3xy? I think so. Is y times positive 2 2y? So I'm undoing it. I'm taking it. It's like a little thing. Good. You getting it?
Wait, so it has to be two things in common?
Yes. Yeah. I mean, eventually it becomes more and more, but those are the first steps. So. So let's take a look at number 6. Take a look at number 6. You with me so far? Actually, we're going to do all these. We'll do them all. All right, so problem number 5. Is 4 the same thing as 2 times 2? And is x squared the same thing as x times x? Is 2 times 2 4? This week. Is x times x x squared? Yes. And then I have 2 times x. Okay. So taking a look at my two terms. My two terms broken up. What do I have in common? What do I have in common between these two underlined terms? I have a 2. Ooh, let's not use that color. That's not a good color because I wrote in red. So I have a 2 and a 2, and I have an x and I have an x. Do you agree? So between the two terms, I have a 2x in common. So I'm going to say 2x comes out front, parentheses. What do I have left behind here? I have a 2x. I have a minus sign that's joining the adventure. Now, ooh, this is a tough one. This is a tougher one. It's an easy one, but it's a tough one because it's like, wait, where did that just come from? If I factored out this 2 and this x, they came out front. What do you think I have to leave behind as a placeholder? What should go right there as a placeholder?
0.
So let's do this. If I go 2x times 2x, do I get 4x squared? Say it one more time. If I go 2x times 2x, do I get 2x squared?
Yes.
I do. 2 times 2 is 4, x times x, x squared. So 2x times what would give you 2x? 1. So 1 is always going to be your placeholder. Okay, so notice I have a 1 that I had to put for that placeholder, and that's important for you to see. Okay, a lot of times students, it's like everything factored out, so I'm not going to worry about it. No, that placeholder has to be there because if I redistributed this back over, it has to give me the original problem. So 2x times 2x, we already said was 4x squared, and 2x times negative 1 is negative 2x. Does that make sense? All right, number 6 switched gears a little bit. We added one more term. I go from 2 terms on number 5 to 3 terms. Okay, so ready? 7x squared is 7 times x times x. 14 is the same thing as 2 times 7 times x. And 35 is what times what? 35 is what times what?
5 times 7.
7 times 5 or 5 times 7? Agree? All right. So friends, what does it look like I have in common between all 3 of those terms? A 7. I got a 7 here, and a 7 here. Agree? Does that make sense? They all have a 7 in common? All right. So I'm going to pull a 7 out front. I could put x back together. What is x times x back together? X squared. Plus sign. The plus has to come along for the ride. What's going to go for the 14? 2x. And the plus sign is going to come along for the ride. What should I have for the third term? I already factored 7 out. 5. Okay? So let's go back and take a look at it. Is 7 times x squared 7x squared? Okay? Is 7 times positive 2x 14x? Is 7 times positive 5 positive 35?
7 times 5?
7 times 5 is 35. 35. I like it. I like it. Use your fingers. That's always a good way to count by 5s. I love it. I love it. It's perfect. Seriously. Yeah. You know the counting by... Nope, never mind. No, I'm not going to do it. I can't remember it. All right. Take a look at number 7. Take an honest look. What does it look like I could break everything down to? Like, what would that break down to into its smallest parts? 5x times x times x. Agree? Minus, what does 10 break down to? 2 times 5. What does x squared break down to? Xx. And then plus 5. Yeah, I'm just showing you, this is what we're basically doing. I mean, you get to a point where you start doing it in your head a little bit. Okay? All right, what do I have in common between all 3 sets of those terms? 5? Okay, they all got a 5. I like this. Do they have anything else? X? Do you agree? So the yellow 5s and the purple are light purple. All right, so if I factor a 5x out of everything, what's x times x? X to the second. The minus sign comes along. What do I have in the middle? What's going to be left over in the middle if I factor the 2x? Plus, don't forget that plus sign. What do I need as a placeholder? 1. Very good. All right, again, my friends, take 1's always there. Good job. 1's always your placeholder. All right, so just double check. Is 5x times x squared 5x to the third? Yep. Is 5x times negative 2x negative 10x to the second? Yeah. Is 5x times positive 1 5x? You factored it. This is the answer. Okay. So you're just breaking it down. You're taking it apart. You're reverse engineering it. Use any term like that you want. You're doing it. Yeah.
Technically, you can put the 5x, you could just like find out what it multiplies to that.
Yep. Yep. You can start doing it in your head. Absolutely. Absolutely. All right. All right. Number 8. 3a, b. Agree? 12 is 3 times 4 times a times b times b. All right.
I know it's not
Oh,
right.
so
It's not right, but why would that work?
because they all have an x in common still. So you try and break it down. So you partially factored it. You didn't factor. You didn't do the greatest common factor. You just did a common factor.
So this answer is wrong.
So all you have to do is make that 5x and make that, and then break it down.
Right. I wrote the right answer here. I just wondering why this one.
Because they all 3 of the terms had x. X. All right. All right. Hey, friends, take a look at number 8. What number do I have the same between them? 3. Agree? Give me a letter they both share. A. Give me a letter they also share. So what comes outside? 3AB. Okay? So friends, see what I highlighted? That's not part of the answer. So what will this part of the answer have if I take a 3AB out of it? An A, plus sign comes along. What about this last part? 4 what? 4B. Okay? We going? We going good? All right. And we're going to do a couple of the homework problems as well as a class. All right. So take a look at this one. Notice, I have this, I have this. Agree? I have x times a quantity, x minus 2, and I have 5 times a quantity, x minus 2. So what do these two terms have in common with each other? I highlighted them. X minus 2. I'm going to keep it in parentheses. Agree? All right. Don't write anything down yet. Don't write anything down. Eyes to the board. Notice, if I factor an x minus 2 out of both, I'm left with x plus 5. And I'm going to put that part in parentheses. Don't forget parentheses. Okay? All right, let's take a look at this last one, and then we're going to work a few. I have this is the same between those two sets of terms. Agree? X plus 3 in parentheses. Okay? I have a 4x here. I have a minus sign. I technically have a 1 right there. This is my answer. Okay? We're going to work a lot with these. You got to trust me. I will get you through it. 1 is a holder. I love it. All right. So, friends, let's take a quick look at 11, 12, 13, or 14. Is there any of those you would like to see worked out a little bit better? Bowden, you got one? 11 through 14. 12? You got it. All right, number 12. 12 is 7 times x, 2 times 7. All right, here's a 7, here's a 7. Agree? So I pull a 7 out front, put parentheses, x plus 2. Done.
X plus 2.
7, and then times x plus 2.
Oh, wait, I'll try to do that.
Go for it. Try 11. Everyone give number 11 a try. Give number 11 a try. Write small so you can make a, if you make a mistake, you can make the correction. Try it. See how you do on number 11. Try it, try it, try it. Ooh, let's take a look. So that's 6x, and that's 6 times 3. Agree? 6 times 8 or 6 times 3 is 18. Yeah. Okay, try number 13. See if you can figure it out. Thank you so much. Try number 13. See if you can figure it out. We're trying 13, right? Yeah.
How many are these? 16?
16 right there. You can factor 4x out of both. So you have 4x outside, and then you have y minus 1 inside.
Can I also do it like this one?
Did you get the same answer as me? Yes. Yes, you can.
Okay.
Wait. For 11?
Yeah, because
Nope.
you can't do that?
No, because you see this 3? So I can still factor a 3 out of both of those.
Oh, okay.
All right. Shh, 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 shh. Bring it back, bring it back, bring it back. Number 13, take a look at the answer I got. Do you agree with that answer? Right? The only thing I can factor out on 13 is they both had an x in common.
Wait, so if the x, how much is 2?
X, like an exponent?
X times 2 or just
It's x raised to the second power is x times x. On that one, because I already factored an x out. So that's a great question. So you're looking at 13, yes? Okay, you ready? So x times 5x is 5x squared. So x times x is x squared. And then x times negative 6 is negative 6x. Well, the 6 is right there. Just the x. You undid it. Took it apart. Because the only thing that work for 5 are 1 times 5. 1 times 6. If I factor 1 out, that means nothing. So 5 and 6 don't have any numbers in common. If I multiply 2 numbers together to get 5, the only way to get it is 1 times 5. And then figure multiplying 6 together is 2 times 3. So you can't. Yeah, but 5 and 6 don't have any common factors other than 1, which doesn't have a common factor. Yep. Take a look at 14, my friends. Take a look at 14. See how you did. It looks like a number and a letter will come out of both of those. 2x, or 2 comes out of everything. That's it. Just a 2. So you have 2 and then 2x squared. And then so 2x squared plus x plus 5. Because 2 times x squared is, or 2 times 2x squared is 4x squared. 2 times x is 2x. 2 times 5 is 10. All right. Hey, who broke 12 down to 6 times 2? Do you feel comfortable with what I did on number 14? Now, some of you might be going, why didn't he use 3 and 4? Because 12 is 3 times 4, right? But I chose to use 6 because I felt that 6 was the largest number that both. 6 times 2 is, huh? You want the largest. That's why it's called the greatest common factor. Greatest meaning biggest. All right. All right. They both have a 6. They both have an x. Agree? So what comes out front? 6x. What do I have left in the parentheses? Careful. 2 times x is 2x plus 3. Done. So you're making sure that's the greatest common factor. That's the big. Well, it's usually going to be this part times that part.
That one, right?
Close. You can take an x squared out of each of them.
So this one should be x squared, not x cubed.
Yep.
This one should be x squared, not x cubed.
Yep.
And this one should just
I'm
be
actually
3x.
going to work it out right now. All right, friends. I'm heading down to number 18. You with me? Ready? 3x to the fourth. X to the fourth is this. Do you agree with that? Plus 6 is the same thing as 3 times 2 times 1, 2, 3. And then 9 is the same thing as 3 times 3. And then x squared is x times x. So look at how number 18 broke down. Now, friends, some of you are going to get to a point where you start recognizing it, and others of you are going to have to continue to write all the way out. What's the right way to do it? Whichever way gets you the right answer. There's no reason why you can't write it all the way out every time. I mean, I'm not going to give you like 3x to the 27th power and you're like 1, 2. No, that's unfair. I'll probably go up to the 26, but 27 is just cruel. All right. So I have 3 parts to this problem. Agree? Okay. So let's take a look at it. Give me a number that is the same on all 3 of the underlying blue parts. 3. Does everyone feel comfortable where that 3 just came from? Now, some of you might be looking at the very end going, why didn't I pick the other 3? I could have. It doesn't matter what 3. All right? What about x's? Do all 3 share at least a single x the same? Yeah, I got an x, I got an x, I got an x. Is there any more x's I can do to all of them? Yeah, there's another one here, another one here, and another one here. Now, right now, I have nothing else that I can take away from the problem. All right, so now, ready? If I can factor a 3xx out of all 3 of these parts, what is 3xx? 3x squared, very good. If I factor a 3x squared out of this very first part, what do I have left? What's xx? X squared. Plus, what do I have left on this part? 2x. What do I have left on this part? Congratulations, my friends. You have just entered your realm of factoring. All right. I think I want to try number 22 as the last one. Can we do it nice and slow? All right. What times what gives me 10? 5 times 2. X squared is what written out? X squared is what written out? X times x. Y to the third is what written out? Good. Y. Plus, break down 12. 12 is the same thing as what times what? 2 times 6. Now, some of you might say 3 times 4. And you're right saying 3 times 4, but are 3 and 4 the same as the 2 and the 5 at all? No. All right. X to the third is what? X to the third is what? XXX. Y to the second is what? Y. All right, going slow. I have my two sets of terms here. Agree? All right. What do I have in common? What number works on both? 2. Is there a letter they share? X. Is there another X or am I done? Yeah. And then we have, you said 2 Y's? I think so. I have this YY and this YY. Agree? All right, so what comes out front? If I have 5XXYY, what is 5XXYY? What is 5XXYY? Y squared. Do you agree? What do I have left behind? What else? Close? You forgot something with a 5. A Y. And then plus 6 and what? 6x. Okay. Hey, my friends, this is a new concept. Agree? Agree? Do you think I think you have it mastered after 31 minutes and 8 seconds? So, my friends, I would like you to try the rest. Now, does it mean, if you try, does that mean you get them perfect? No. Try the rest of these. Okay? See what you can do. Also up here, try these. These are the reviews. This is a review. Okay, so complete this entire worksheet. Okay, front and back. You have time to do it.